So hello everyone, my name is Meet Sangvi and I'm a student of third year in electronics engineering from DJ Sangvi College of Engineering. And today we are going to be looking at the circuit of an integrator using op-amp OP07. So this is a circuit. So first the value of the capacitor, we've taken it as 0.01 microfarads, and accordingly we calculate the value of RF by using the formula 1 upon 2 pi FA into CF, which gives us 15.9 kilo ohms, and R1 as 1.59 kilo ohms. And yeah, this is the ROM, that is the compensation resistance. By calculating we get it as 1.445 kilo ohms. So yeah, this first we will be doing it for a sine wave. So so we right click on the voltage, click on sine, and the DC offset will be 0 because we don't want any offset. The amplitude will be 1 and this will be 1 kilo hertz. Press OK. I will move this a little bit. Yeah. Then for the simulation command, we'll take it as 0.005, that is 5 milliseconds. Press OK. Place it over here and then run the circuit. So as we can see that the input wave, that is in green, is a sine wave, and the output wave, which is in blue, is a integration of the sine wave. So basically the output is the integration of the input, which is a cosine wave. So we can see that clearly over here. Now if we want to increase the frequency from 1 to 10, let's say, and then we run it. Okay. So now we can see that the frequency has approached the upper cutoff frequency, and we can say that there is a phase difference between the input and the output. So the output is out of phase with respect to input over here. Now we can look for a square wave as an input. So we right click on the voltage over here, we select pulse. This V initial will be -1, V on will be 1, delay will be 0, T rise will be 0.001 microseconds, T fall will be 0.001 microseconds, T on will be 0.05 milliseconds, and T period will be 0.1 milliseconds. Press OK. We move this. Yeah. So now we run this. So as we can see, the input is a square wave, and we press on output, and so yeah, we can see that the input is square wave and output is kind of triangular wave. And yeah, so this is because this thing over here is because of since the capacitor here takes time to charge at first, that's why we see this kind of shape, like it's coming from 10 volts gradually decreasing. So yeah, so for that we can just change the axis from 1 to 2, and tick will be 100 microseconds. Okay, sorry, milliseconds. And this can be from 2. So yeah, we as you can see that we have given this we give square wave as an input, and we get as triangular wave as the output. So now we will look for a triangular wave as input. So we first right click over here, select pulse, and it will be v initial will be -1, v on will remain 1, time t delay will be 0, and this will be t rise will be 0.05 milliseconds, t fall will be the same 0.05 milliseconds, t on will be 0, because we don't want a flat line, we want a peak over there, and yeah, t period will be 0.1 milli. We press OK, and then we run. We press on input, so we can see that the input is triangular in wave, and the output is kind of sinusoidal. So this is also because of this because of the capacitor. We can do it over here by right clicking on the axis from 1 milliseconds to 2 milliseconds, and tick will be 100 microseconds. Similarly, the y-axis will be from 1. Okay, so the input in green is in triangular and the output is in sinusoidal. And so we can now go for the frequency response and the phase response. So first we can just right click over here, and we can do it over none, because we don't want any kind of output input. We then give AC amplitude as 1, press OK, and then edit simulation command, or we can just right click over here, so it will give us this. We want AC analysis, we'll take decade over here, number of points per decade will be 500, start frequency will be 1, and stop frequency will be 100k. We press OK, so, and we run. So if we click on the output, we can see that the dark line is the frequency response, dark green is the frequency response, and the light green is the phase response. So if we want to remove the light green, like the phase response, we can just right click on the axis over here, don't plot phase. So yeah, seeing this frequency response, it is at 1 kilohertz. So like if we see it at 1 kilohertz, it is around 16.91, so which is minus 3 dB less, which is 3 dB less than the gain at 10 kilohertz, which is 3 dB less than the gain, and at 10 kilohertz we can see it as minus 0.188, which is approximately 0, which is the upper cutoff frequency. So 10 kilohertz is the upper cutoff frequency, and yeah, so at this line over here, this is a constant, because at lower frequencies it acts as a low pass filter that allows only frequencies below lower cutoff frequency to pass through it. So yeah, that is it. We just cancel this. Thank you everybody.